So in today's lecture, we will discuss about the equation of a tangent line. But before that, let's have a quick review of coordinate geometry. So let's say we have the xy plane. So this is the x-axis and we have the y-axis. And let's suppose we have a point lying on the xy plane with the coordinates x1 and y1. And we have a line that passes through this point. And this line, let's say it has a slope of m. Then the equation of this line, which is given by the point slope form, so that will be given by y minus y1 equals to the slope m times x minus x1. So we will be using this particular formula on the point slope form of a line to find out the equation of a tangent line. So what we will do to determine the equation of a tangent line, we consider an xy plane. We have a smooth curve, smooth in the sense this is continuous on the interval, let's say x1 and x2. Now we will consider a point on this smooth curve. Let's say this is defined at x equals to a, which has a corresponding y value of f of a. So that means the coordinate of this particular point is going to be the x coordinate, which is a, comma the y coordinate, which is f of a. Then if we draw a tangent to this curve at this particular point, then the equation of this particular tangent line, which is a straight line, so that will be given by, we will use the point slope form. So we will have y minus y1. So y1 is the y coordinate of that particular point, which we have considered, which is f of a, equals to the slope. We'll come to the slope in a moment. The slope times x minus x1, and x1 is the x coordinate of that point. So this is a. Now the slope is actually given by the derivative of this curve. The derivative of the curve is defined as the slope at that particular point. Let's call it P. So this is the equation of a tangent line. Okay, so let's try to use this particular expression to find out the equation of a tangent line. So we'll consider our first example. Let's say we have a curve which is given by the function x squared. So this is a parabolic function, or also referred to as the power function in general case. So we have the x coordinate and the y coordinate. So the parabolic function is which represents a parabola with its vertex at the origin O. Now let's say we have a point P here, and let's say this point we want to find the let's give it a name, x is equals to 2. So we want to find the equation of the tangent line at x equals to 2 for this particular curve. So let's do that. For this we need what? We need the coordinate of this point P. So the coordinate of the point P will be, so that's the value of x at that particular point, which is 2, and then the value of the function at x equals to 2, which will be f of 2. So our function is f of x given by x squared. So this implies that f calculated at x equals to 2, so this will be equals to 2 squared, which is equals to 4. And also we need to find out the slope. The slope will be simply the derivative of the function, which is equals to, so derivative of x squared we have done it countless number of times, so this is simply 2x, which can be obtained by using the power rule, right? And the value of this slope at x equals to 2, so that will be equals to 2 times 2, which is equals to 4. So that means the equation of the tangent line, so we can use this equation. So our equation will then be y minus y1, so this is actually y1, minus 4 equals to the slope. The slope at that particular point is 4 multiplied to x minus x1, and our x1 value is simply 2. So we can solve this. So we have y minus 4 is equals to 4x minus 8, or this gives us 4x minus y is equals to 4. So this is the equation of the tangent line. So if we draw a tangent, which will be a straight line at that point which touches the curve at that point P, the equation of this tangent line is going to be 4x minus y is equals to 4. Let's try another problem. So this time, let's say we consider the cubic function. For example number 2, we are going to consider the function x cubed. So the cubic function has the form, right? You can use desmos.com to obtain the graph of this particular cubic function. So let's say we want to find out the equation of the tangent line at this point. So let's say this value is x equals to 3. Fine. So when we have x equals to 3, then its corresponding y value is going to be f of 3. G of 3, since we have used the function g, so this will be g of 3. So we have, so the coordinate will, the point will be 3 comma g of 3. We need to find it out. So let's find out g of 3. So g of x is given as x cubed, so g of 3 will be 3 cubed. So this is 3 raised to the power of 3 is 27. Fine. So that means the coordinate of our point, so this is 3 comma 27. Now we also need to find out the value of the slope. So the slope will be given by the derivative of the function g of x, which is x cubed, that is 3x squared. So at x equals to 3, so this will be 3 times 3 squared, which is also equals to 27. So that means our equation of the tangent line at the point 3 comma 27 will be y minus y1, which is 27, equals to the value of the slope at that particular point, which is 27, times x minus x1. So our x1 value is 3. So this is the equation of the tangent line. We can simplify this and this will give us, so we'll have 27x minus y is equals to 54. So this is going to be the equation of our tangent line. Let's move on to the next problem. Example number 3. So let's say we consider the function 1 over x. So 1 over x is simply the function which blows up near the origin, and that is going to decrease as x increases. So let's say we want to find out the equation of the tangent line at the point x equals to 2 and f of 2. So that means at the point 2 comma f of 2. So the equation of the tangent line means we draw a tangent line which touches the curve 1 over x at this particular point P. That's all. So at x equals to 2, the value of the function is going to be 1 over 2, which is 0.5. Or we can use 1 over 2. We'll use it later. Then the slope f prime x, so that's given by derivative with respect to x of 1 over x, or simply x raised to the power of negative 1. So this gives us negative 1 times x raised to the power of negative 1 minus 1, or simply negative 1 over x squared. So that means at x equals to 2, the slope value will be negative 1 over 2 squared, which is negative 1 over 4. So let's use the equation. So this is equivalent to 2 comma half. So that means our equation of the tangent line will be y minus, we have y1, so our y1 value is half, equals to the slope, which is negative 1 over 4, multiplied to x minus x1. So x1 is 2. So we can multiply throughout, but let's do it with 4. So we have 4y minus 2 is equals to, so we have negative 1. So negative 1 times x will be negative x plus 2. Rearranging everything should give us x plus 4y is equals to 4. So this is the equation of our tangent line, which is x plus 4y is equals to 4. Right. Let's move on to the next problem. So we have our exponential function and we want to find out the equation of the tangent. So first let's try to sketch the exponential function. So this is a function. So we have the x-axis, the y-axis. So since this is an increasing function, e raised to the power of x, which is an increasing exponential function, so this is going to increase as x increases. So let's suppose we want to consider the point at x equals to 4. So its corresponding y value will be simply e raised to the power of 4. So that means we have the point P defined as P4 comma e raised to the power of 4. So what is the equation of the tangent at this particular point P? Okay, equation of the tangent that passes through this point P. So we have h of x, which is given by e raised to the power of x. So we have already obtained that x equals to 4. We have e raised to the power of 4, and this is a y coordinate. Then we have the slope. So our slope will be h prime x, which is simply the exponential function itself, because the derivative of the exponential function gives the function itself. So at x equals to 4, we have e raised to the power of 4. So the equation of the tangent line will be y minus y1. So this is e raised to the power of 4 equals to e raised to the power of 4, which is the slope, multiplied to x minus x1, which is 4. So this is the equation of our tangent line at that particular point P. We can also find out the equation of the tangent line at different points as well. So let's say we consider the equation of the tangent line at the origin. So that means at x equals to 0, right? So we have h of 0 will be equals to e raised to the power of 0, which is 1, and this is our y coordinate. So that means our new point P is given by 0 comma 1. So this is x1 and this is a y1, and the slope will be h prime of 0, which is equals to e raised to the power of 0. So that is also equals to 1. So that means our equation will be y minus y1 equals to slope times x minus x1. So we have y minus 1 equals to x, or simply x minus y is equals to negative 1. So this is the equation of the tangent line. So this, write it down. So this is x minus y plus 1 is equals to 0. So this is the required equation of a tangent line.